All right, we've got Algebra 2 ISA 2A13. The student will solve and graph compound inequalities. Compound inequalities, there are two classifications, conjunctions and disjunctions, and we'll get into what they are, that means, and all that good stuff throughout the course of the lecture. Hopefully I'll make sense. Here we go. We can think of compound inequalities as two inequalities that we solve at the same time, and we sketch them on the same number line. That's what compound inequalities are. Two inequalities, we're going to solve them at the same time, sketch them on the same number line. Okay? Conjunctions, emphasize the conjunctions and disjunctions is what we're going to be talking about. Conjunctions, disjunctions. We're going to talk about conjunctions first. Conjunctions are also called and statements. And we only concern ourselves in conjunctions with where the graphs overlap. We're going to solve two inequalities, and we're going to graph them both. And we're only concerned where those two graphs overlap each other. That will be the solution. If they don't overlap, there's no solution. Okay. Solve and sketch. So here we go. It's an and statement. In this case, you can see the word and. You can't always see the word and in a conjunction, but in this case you can. So I'm just going to solve both of these inequalities. I'll solve this one. I'll solve this one. I'll see what they both look like on the number line, and I'll only graph the part that overlaps, where they both overlap each other. So here we go. I'm going to solve this one by subtracting 10 from both sides. I was about to say, if you see me make a mistake, please tell me, but there's no way you can do that. So I will try not to make any mistakes. And if I make one, I will probably cry. Here we go. I'm going to subtract 10 from both sides. I'm going to bring down my negative 4p. That turns to 0. This is greater than, and what is that, negative 32? They're the same sign, so I add and keep the sign. Now I'm going to divide by negative 4. And remember, when you divide or multiply both sides of an inequality by a negative value, the direction of your inequality changes. So with that in mind, this is going to change directions. I'm dividing by negative 4. My p is all by itself now. Negative 4 divided by negative 4 is 1. 1 times p is p. This changes directions. It's no longer greater than, it's less than. 32 divided by 4 is 8. Negative divided by negative is positive, so p is less than 8. That's part of my solution. And now I'm going to solve this one and try not to make any mistakes. Adding 3 to both sides yields 9p is greater than or equal to negative 27. Now notice I added 3. The only time this changes directions is if you multiply or divide by a negative. You can add and subtract all day long, it won't change the direction. I'm going to divide by positive 9, so that won't change the direction. Only if you multiply or divide by a negative. So I'm dividing by positive 9. That won't change the direction of my inequality. 9 over 9 is 1. 1 times p is p. This does not change directions because I divided by a positive. And 27 divided by 9 is 3. If one of the numbers is negative, the quotient is negative. And so I've got two situations here. I've got p is less than 8 and p is greater than or equal to negative 3. That's our solution. It could also be written as one statement. If you put the smallest number on the left and the larger of the two on the right and put the variable in between them and orient the inequality symbols so that they're both like this, it'll say the exact same thing. Whoops. It looks like we've changed directions of one of those inequality symbols, but we haven't. This is p is less than 8. There's that part right there. P is less than 8. And this says p is greater than 3 if you read it backwards. That should be or equal to. P is greater than or equal to negative 3. So you could write this like this if you wanted to. Don't have to, but you could. In graphing it, you would go like this to graph it. Negative 3 goes to the left, and 8 is on the right because 8 is larger than negative 3 on the number line. It's to the right of negative 3. And I would think to myself, this is just thought bubbles here. This is just me thinking. This is everything smaller than 8. Well, that would be an open circle here. This is not the graph. This is just me thinking. If I were going to graph just this, it would look like this. Open circle everything to the left. But I got to keep this one in mind. P is greater than or equal to 3. So here's the other thing I'm thinking. P is greater than or equal to negative 3, I'm sorry. I'd have a filled in circle and everything to the right. And I think, hopefully, you can see where I'm going to overlap them. They'll overlap right here and here. This will be filled in. Everything in between here is where they overlap. See how they overlap? That's where they're both true. Both of these inequalities are true in this region, this interval between negative 3 and 8. Every value between negative 3 and 8 will make both of these inequalities true. That's an and statement. It's called a conjunction. Okay? We're concerned with where the graphs overlap. And so I did this. This is just me thinking. That's not part of the graph. This is the graph. Okay? So I would look for either this or this in this graph. It'll have the solution and the graph. Here's another conjunction. The reason I know it's a conjunction right off the bat, there are conjunctions and disjunctions. And if your combined inequality or compound inequality doesn't have the word or in it, if it doesn't have that word, it's a conjunction. If it does have the word or, it's a disjunction, and we don't worry about where they overlap. Hopefully that will make sense here in just a second. I look up here and I say, hey, this is a conjunction. So all I'm going to do is solve it just like I would a normal everyday inequality, but instead of doing something to both sides of the inequality, I've now got 3 sides. I've got negative 41 is less than or equal to 4x minus 5, which is less than 23. So I'm going to add 5. Normally it would be to both sides, but I've got this to consider too. So I'm going to add 5 in 3 places instead of 2. So I'm going to add 5 here, here, and here. That's going to make this 5 disappear. Then I'm going to divide everything by 4. I'll divide that by 4, and this by 4, and this by 4, and I'll have my solution. So here we go. I'm going to add 5 to get rid of this. I'm trying to get x by itself. So I get rid of this by adding 5 in 3 places. It's just like you think of them as if they were equal signs. They're not. But, then I rewrite my equation. What is that? Negative 36 is less than or equal to 4x. This is gone, which is less than, was that 28? And now I'm going to divide by 4. To get this x by itself, I divide by 4. So I divide this by 4 and this by 4. If I divide this by 4, I've got to divide all 3 places by 4. So I divide this by 4, and consequently I've got to divide that and that by 4. So now I rewrite, negative 36 divided by 4 is negative 9. Which is less than or equal to 4x over 4 is x. That's 1 times x is x, which is less than 28 over 4, which is 7. 28 divided by 4. 28 fourths is 28 divided by 4. So here's my solution. This time, remember I said up here on this conjunction, I said you could write these 2 inequalities with an and in between them as one conjunction by putting the smallest one on the left, the larger of the 2 on the right, and orienting our inequality symbols so they're both like this. Well, if it starts out a compound inequality like this, if it's already written like this, that's what's going to look like when you're finished. You don't see the word and, but it's implied, it's there. I know it's there because it's a conjunction because it doesn't have the word or. So then I just go to graph it. This is my solution. Here's my graph. Negative 9 is to the left of 7 on the number line. This one will be filled in because it says or equal to. This one will be open. It will be everything in between them. X is less than 7 goes this way for infinity. Goes infinitely to the left. This is just me thinking. Looking at this one, reading it backwards, x is greater than or equal to negative 9 would be everything filled in and going this way. You don't have to do this part, this is just me thinking. And you can see where they overlap. They'll overlap right there. Okay. So that's the two ways that you'll see conjunctions. Conjunctions and statements. We only concern ourselves with where the graphs overlap. The last type we're going to be dealing with is called a disjunction, and I can glance at this, and I know it's a disjunction because it has the word or in it. I'm just going to solve both of these, graph them on the same number line, and I don't care whether they overlap or not. If they overlap, fine. If they don't overlap, fine. That's the thing about an or statement is it could be this one or that one. What we're talking about up here is where they're both true. That's the intersection of these two. The intersection is where they overlap. Here, we're going to talk about where either one of them is true. We think of that as the union. It's where they're both true. So I'm going to solve both of these, try not to mess it up when I'm going through the motions here, and hopefully I'll get it right. Here we go, -2, I'm subtracting 2 and then dividing by -7. When I divide by -7, that will change the direction of my inequality. So I'm subtracting 2, rewriting my inequality, -7p comes down. I don't change my direction yet because I haven't divided by a negative yet. Only when you multiply or divide by a negative. These are the same sign, so I add and keep the sign. Now I divide by -7 to get this p by itself. I divide by -7, that's -7 times p. Excuse me. That will change the direction of my inequality when I rewrite this. I've got to also divide this side by -7. Whatever you do to one side of an inequality, you must do to the other side. When I rewrite this, -7 divided by -7 is 1. 1 times p is p. The direction of my inequality changes. 70 divided by 7 is 10. Negative divided by negative is positive. So here's part of my solution. All values bigger than 10. Now I'm going to solve this one. I'm going to add 2 and then divide by 8 to get p by itself. So I'm adding 2. Rewriting my inequality because I'm not in a hurry. I believe that's -24. -26 plus 2 together. Different signs, so I subtracted, kept the sign of the one with the greater absolute value. Dividing by 8. This won't change the direction of my inequality because I'm not dividing by a negative. 8p divided by 8 is just p. This stays the same direction. 24 divided by 8 is 3. If one of the numbers is negative, the quotient is negative. So I've got this or this. I've got an or statement going on here. So when I go to graph those, I don't care whether they overlap or not. I just draw a number line. And I put a couple places on there, and I say, well, -3 is to the left of 10 on the number line. And if I was going to graph all values bigger than 10, all values greater than 10, I would have an open circle on 10, and all the values to the right would be shaded. If I were going to graph all values less than -3, that would be an open circle on -3. I think it was open. Let me make sure I didn't drop my or equal to symbol. Nope, I didn't. I'm good. All values smaller than -3 would be to the left on the number line. Don't forget to shade the arrow. Okay. And that is what the graph of all the solutions to this compound inequality looks like. Infinite number of solutions, everything to the left of -3 on the number line or to the right of 10 on the number line are the solutions of this. So if you were going to be taking a quiz that involved multiple choice, you'd be looking for this combination, this and this graph, okay? A lot of times it's just easier to find the graph and then make sure that they have that right. So there we are. I believe I'm finished with that. Yeah, I am. Okay. So there we are. There will be a couple of worksheets that are attached to this. I hope that made sense. Best of luck.